13 on the 5th of May. This is my Mobius strip. It's a three-dimensional manifold. It has one surface, one edge. It's got three twists in it. It's my Mobius paper where I've been cutting it down the middle. I'm going to explain how we go from this to this knot diagram to this. So basically, you cut the Mobius strip down the middle, and you get this. It's now a two-surfaced object with two edges, a white edge, a black surface, a white surface. You can organize this into a little coil, which looks like this, but you actually got to flip this around itself to organize it this way. You can see where it crosses itself. You add a half snip on each side of that, and you can then make this little beastie. It's quite neat. And then this gets laid on the page, and you draw the knot diagram, which is this. And then I've taken it apart. It took me a few hours of reading to know that's the right thing to do. But if you imagine that the coil can pass through itself, we can look at a demonstration. They're called Whitney Tricks, and that'll be seen right here. You can see this is the same idea, and you're not allowed to pinch this off and make a sharp bend, but you can pull it apart. So that's like a Whitney trick. It's a way to undo the double points so that basically a manifold can cross itself to undo a double point, so you get the unknot. But before you get to making this last maneuver to get the unknot, you got to imagine that the knot can pass through itself. So there it is there with no crossings. I pulled the middle out. You see it's outside. The next loop gets pulled out, and then the next loop gets pulled out, and then we're left with this. Now that has 4 loops in it, and if that was a paper loop, if that was a strip of paper with 4 loops in it, it would actually have 8 twists, because a loop of paper cancels 2 twists. So that diagram there cannot be turned into the unknot because it's not reducible. There's 2 of those. There's this knot here and this knot, but these don't make the unknot, which is quite interesting. And that diagram there represents the 8 twists, because with the Mobius strip, when you cut it down the middle, that has 2 surfaces, a black surface and a white surface, but it has 8 twists in it. And the formula for that is 2n plus 2. So we started with 3 twists, times by 2 is 6, plus 2 is 8. That's how you get the 8 twists. And it's really beautiful that when this three-dimensional object is reduced with Whitney tricks in the knot diagram, we can see where the 8 twists still are. And that was my last discovery with the Mobius topology. Really boring. Really, really boring.